Okay, so what I'm going to show you here on this video is how to find the area of similar polygons. And this is something basic we're going to have on our test. If you're just a subscriber to my channel, this is going to be kind of geared towards what my students are going to see on their upcoming test, but it actually is going to be a helpful video. I'm going to show you multiple ways to compare areas and find areas and how areas are related in similar figures. So first of all, let's review what a similar figure is. Okay, a similar figure, remember by definition, if we talk about similar figures, and we're going to just say all similar figures, they are same shape, exact same shape, different size. That's just the layman terms for it. I'm not going to get more complicated than that, because when we talk about congruence, we talk about same size, same shape. When you look at similar figures, they're the same shape, they're just not the same size. So basically they're going to have a common scale factor and things like that. So let's look at what similarity means. The thing that you're going to see with similarity also is you're going to see a scale factor. Okay, so you'll see a scale factor. I have a video on similar figures, but I'm going to go ahead and put some of this in here just because you have it in one place. The scale factor, okay, the scale factor establishes the relationship between the figures, and that relationship being the actual factor that was used, whoops, that's a horrible line, the actual factor that was used to increase or decrease. When we look at stuff like this, we're technically looking at dilations. And if you've done anything with dilations, dilations are when you keep the same thing, you keep it the same shape, but you don't keep it the same size. When you go to the doctor and have your eyes dilated and you have to wear your big grandma glasses when you leave, the big sunglasses, it's because they've dilated your pupils, the doctors have. Your pupils regulate the amount of light that comes into your eyes, and so all circles are the same shape. That's not something you have to worry about with circles, but what happens is when they dilate your pupils stay circular, but they dilate and they get bigger, and so they're letting in more light than normal, which is why you're sensitive. So a dilation is just basically the same kind of thing with dilations. All right, so let's look at what a scale factor is. Now, when we have figures, I'm going to give you two similar figures here. I'm going to draw them out, and we'll start simple. Let's look at similar triangles. So I'm going to draw a triangle here, and I'm going to say that this is 6, and this is 6, and this is 8. And then I'm going to draw another triangle here, and I'm going to say that's 12, and that's 16. Now, I'm going to tell you that these are similar. So, knowing that they are similar, you can actually assume that all the ratios are going to be the same. So, basically the scale factor is a ratio. Now, you can determine if something is similar without being told. In this situation you can, because you're given all the sides. You can verify that all the ratios are the same. Now, what the scale factor is, we call that K, the scale factor. And that is going to be the image, which is your new object, divided by your pre-image, which is your old object, your original. So here's your pre-image, and here's your image. So when I take the image and divide it by the pre-image, it shouldn't matter. As long as I can match up the sides, then I will actually be able to get the scale factor. So let's look at all these. Let's assume I have them written in the correct orientation. So 12 over 6, and that would give me 2, a scale factor of 2. Now let's do this one. That's also going to be 12 over 6, which is 2. And then I have 16 over 8. 16 over 8 is 2. That verifies that they are similar. All of them have the same scale factor or ratio. Scale factor can be called a ratio as well. So that basically means if the scale factor is 2, I multiplied the original figure by 2 to get the new figure. This is going to be important when we start looking at areas. So now that we've had a quick review of a scale factor, let's look at an example of how the areas are going to be affected. Okay, so let me give you a picture. And let's use this one. I'm going to tell you, I'm going to give you, we're going to start off with a triangle. And we're going to assume that these two triangles are similar. I'm going to tell you that they're similar in this case because I'm not going to give you all the information you need. And I'm going to tell you that the base of this one is 10 meters and the base of this one is 30 meters. Okay? And then I'm not going to tell you what the height is. And I'm not going to tell you what the height is here. What I'm going to tell you is I'm going to tell you the area of this one is going to be 25. And I'm going to ask you what's the area of this one. There are two ways you can solve this. The first one is I can do 25 and plug that in and set that equal to the formula. So what's the formula? Area formula for a triangle is base times height divided by 2. What's my area? It's 25. My base is 10. I don't know my height. It's divided by 2. And then you can set this up and solve. 25 over 1. You cross multiply. So 50 equals 10h. You divide both sides by 10. My height is now 5. So if I know my height is 5, how did I get from 10 to 30? Well, remember your scale factor is pre-image over pre-image. So 30 over 10. So my scale factor is 3, right? Well, that means that I multiplied the pre-image times 3 to get the image. Well, so that means I multiply 5 by 3, which means what? My height has to be 15. And now I can do the formula for the area of a triangle. I can do 15 times 30 divided by 2. That's method number 1. But I'm going to show you how the areas actually compare to each other because sometimes it's not so straightforward. All right, let's pretend, again, let's take these out of play. I'm going to take them out of play. Let's say I don't want to do all that. Let's say I just want to figure out what this new area is without having to do all that extra stuff. Well, when you do a scale factor, how many times did I multiply 10 by 3 to get 30? When I increased the size of this triangle, when I increased the size of this triangle, I had to multiply the base by 3. But what else am I having to multiply by 3? I have to multiply the height by 3 also. So how many times am I actually multiplying by 3 to increase the size of my triangle? Twice. So when you do one dimension, like side to side, you multiply by 3 once. When you go from area to area, you multiply by 3 twice. So the area is going to be the original area times the 3 I had to multiply by to change this side, times the 3 I had to multiply by to change this side, which the formula writes it as 3 squared. So I have 25 times 9 is what I have. And that comes out to 225. Okay, 225. And that is meters squared. That's a lot quicker than having to go through all of those calculations, because once I get that this is 5, I then figure out that this is 15, and then I have to do 15 times 30 divided by 2. And that does still get me to 225. So basically what happens when you compare an area to another area, once you change it using the scale factor, you're going to multiply it by that scale factor twice. Because in figures like this, in order to preserve the dimensions, you have to multiply each of the 2 dimensions, these are 2-dimensional objects, by the same scale factor. So let's do another example. I'll do one more example of this one. And let's see here, I've got some paper here on the floor. My children were running in and out. So let me give you another example. Let's do a regular polygon. Okay? So, you can hear my kids yelling. Let's have a regular polygon. And I'm going to actually make this a different kind of dilation here. We're going to get smaller. And let's pretend, like I said, for a minute that I can actually draw. So these are going to be regular pentagons. We're going to assume that these are regular pentagons, okay? That's important. What is the formula for the area of a regular pentagon? Well, remember, any regular polygon is the apothem times the perimeter of the pentagon, or the polygon, times 2. So what I'm going to provide you with on this one is I'm going to provide you with one side. Let's say this is 5 inches. Okay, this is 5 inches. And I'm going to provide you with the area. Now let me think of a good area. I'm trying to think of something where I can give you something that's actually going to be decent. I've got to have an apothem in mind so that I can make it to where you can do a decent calculation. So the perimeter of this guy would be 25. So 25 times 3. Okay, here, hold on a second. 5 times. All right, give me a minute. All right, so I'm going to make the area of this pentagon, this regular pentagon, 100 inches squared. And sometimes, if you want to get real picky, this may not be possible with a pentagon like this, because it's all based on angles and everything, but just to make it easy for you, we're going to do this. All right, so we're going to say that that's 100. I'm going to say that this right here is 2 inches. And I'm going to ask you, what's the area? Well, first of all, let's find the scale factor. Remember, we talked about scale factor. So let's talk about the scale factor. Remember, the scale factor, which is K, is going to be your image divided by your pre-image. Image divided by pre-image, okay? My image is 2. My pre-image is 5. So my scale factor is a nice, ugly 2/5. Now basically when the scale factor is less than 1, that indicates that the dilation is a reduction. What we saw in the previous example is an enlargement, like when you enlarge a photo to poster size. You're enlarging it proportionally. Here we're shrinking it and reducing it proportionally. So my scale factor is 2.5. Well, let's look at the formula. That means that each side, that to reduce the sides, I had to multiply them by 2/5, and whatever my apothem is in the original, I had to multiply my apothem times 2.5 to get my new one. So once again, how many different things am I multiplying by 2/5 to get the new figure? Each side, that counts as 1 because all of the sides fall under that same umbrella, and the apothem. So the area of my polygon here is 100, but the area of my new one, remember, instead of multiplying the scale factor once, you multiply by the scale factor twice. And this is how you multiply fractions. If you've forgotten, you go straight across. So I get 400 divided by 25. Okay, 400 divided by 25. So my new area, how many times does 25 go into $4? Is 16. So the area here is 16 square inches. Now, how does this relate to this? Remember on the other one, it was, instead of being 3 times, it was 9 times? Well, 9 was 3 times 3. Here we have a reduction, so it's 2/5 over 2/5, which means it reduced by 4/25. This is how we reduce the area. Just remember, to reduce the area or increase the area, you multiply by the scale factor, the original area by the scale factor twice. Okay? Now what if I gave you the area of this one and told you to find the area of this one? You would do it the same way, except instead of multiplying the area by the scale factor, to go backwards from the image back to the pre-image, you would divide by the scale factor twice. So I would divide by 2/5 twice. In the previous example, let's say in the previous example I provided you that I gave you that the area was 225 and I didn't tell you this one, I would divide by 3 and divide by 3 to go backwards. If I do 225 divided by 9, I'm back at 25. So if you're going from the image back to the pre-image, you divide by the scale factor twice. If you're going from the pre-image to the image, you multiply by the scale factor twice. And that is how you do the areas of similar polygons.